Okay, so this is a pre-calculus review in preparation for Unit 6, Techniques of Integration. We're going to begin with polynomial log division. Integrals to which the log rule can be applied often appear in disguised form. For example, when a rational function has a numerator of degree greater than or equal to the degree of the denominator, division may reveal a form to which you can apply the log rule. So let's start with example 1. And we know that we can't use the synthetic division because we are dividing by a quadratic. So we're going to divide x squared plus 1 into x squared plus x plus 1. So we know that x squared goes into x squared one time. So we have then x squared plus 0x, because there is no x term, plus 1. And then we're going to subtract this. So we end up with an x as a remainder, which means this rational function can be simplified to 1 plus x over x squared plus 1. All right, so let's go ahead and take a look at example 2. And again, we're going to be dividing a quadratic of x squared minus 5 into x cubed minus 4x squared minus 4x plus 20. So x squared goes into x cubed x times. So we have x cubed minus 0x squared minus 5x. Again, we're subtracting. So we have negative 4x squared. Negative 4x minus a negative 5x gives me just plus x plus 20. And then now x squared goes into negative 4x squared minus 4 times. So we have negative 4x squared plus 0x plus 20. And again, we're going to subtract, which gives us just x, which means this rational function simplifies to x minus 4 plus x over x squared minus 5. Okay, so our next pre-calculus technique is going to be completing the square. And completing the square will help when quadratic functions are involved in the integrand, and it will force the integrand into one of the inverse trigonometric forms. So we're going to complete the square of the denominator of 1 over x squared plus 4x plus 13. Now, what's different about these than what you've done in pre-calculus is we don't have an equal sign where we're working on both sides. So if we have 1 over, and I'm going to x squared plus 4x, and I'm going to leave a space and then move the 13 over. And the technique is going to be the same. I'm going to take this middle term of 4, divide by 2, which gives me 2, and square it. And I'm going to add 4, and then I need to subtract 4 because I'm still working on the same side of the equal sign. So this then gives me 1 over x squared plus 4x plus 4 plus 9. I recognize that I'm trying to look for probably an inverse tangent form. So this becomes 1 over x plus 2 quantity squared plus 3 squared. And now I have this into something that I can ultimately integrate. So let's go ahead and take a look at another example. And this time we are working inside a square root. So we have 1 over the square root of negative x squared minus 4x. So what I'm going to do is I'm going to say, okay, 1 over the square root. I know there's going to be a number to the left of this negative sign, and I'm going to factor out that negative. So x squared plus 4x. Now again, I'm going to take this middle term, and I'm going to divide by 2, and then I'm going to square it. So plus 4. But remember, I'm actually subtracting the 4 because of this negative. So then I can put this 4 here, which then gives me 1 over the square root of 4 minus parentheses x squared plus 4x plus 4. Recognizing I'm looking for inverse sign, this is going to be 1 over the square root of 2 squared minus x plus 2 quantity squared. All right, and then our last example is going to be another one where we're completing the square inside the square root. So we have 1 over x minus 1 times the square root of x squared minus 2x. I'm going to take, again, the middle term here, divide by 2. I get 1, square it. I have plus 1, and then minus 1. So which then I have 1 over x minus 1 times the square root of x squared minus 2x plus 1, I'm going to throw that in parentheses, minus 1. And so I can simplify that again to 1 over x minus 1 times the square root of x minus 1 quantity squared minus 1 squared. And you should recognize this as arcsecant.